field campaign happened to be here just as an unusually dry season led to some of the most intense and large fires the region had experienced in the last 5 years.
We came here to look at the transport of smoke and what smoke does in the environment, particularly as it impacts clouds. And we had an amazingly intense smoke event that carried very high concentrations of smoke into a place called the Sulu Sea.
You might be surprised to learn that fires affect cloud formation, and NASA is studying that dynamic relationship.
NASA is a big and capable organization, but earth science is a subject far too big for one country, one agency to tackle all by itself.
And when you can't do it by yourself, you call up your colleagues halfway across the globe. We're in the Philippines to better understand how tiny particles from smoke and pollution affect cloud formation. The campaign is called the Cloud Aerosol and Monsoon Processes Philippines Experiment, CAMP-X. The 2 is silent. That's just a joke, but the acronym, that's serious. This project has implications for millions of people.
I'm the program scientist for CAMP-X, and while I'm here, I'm sort of the decision maker of last resort if something comes up.
We caught up with Hal between meetings in the hangar. Along with Jeffrey Reed from the Naval Research Laboratory, he's responsible for overseeing this large collaborative effort in real time, making sure the team is meeting their scientific goals while also keeping researchers from institutions around the US and the Philippines working together smoothly.
A critical part of the process was the relationship built through time. That relationship enabled us to really work together and think about what would be the questions that would be relevant to us in the Philippines and in general to the region. I'm Gemma Teresa Narisma, and I'm the Executive Director of the Manila Observatory.
The Manila Observatory, along with NASA, the Naval Research Laboratory, and a handful of university partners are using 2 research planes and measurements from a ship to look at the properties of clouds to improve satellite measurements in the region.
Satellites find it difficult to see, quote-unquote, this region, and regional climate models are having a hard time capturing these processes.
That basically means planes, ships, and teams on the ground need to fill in the missing details. Which brings us back to the most intense fire season in 5 years.
We were able to get the P3 into that smoke and make absolutely unique and important measurements.
It's important because if we cannot get the historical observations in our model, then we're not so certain whether our climate projections are correct.
When the planes aren't flying, the science teams and flight crews take turns visiting local schools, from elementary up through university.
Elementary school students can understand remarkably complicated concepts. And so it's kind of fun to introduce them to things they may not have known or thought about before. And it's remarkable how quickly they pick up on it.
At these schools, the scientists are treated like rock stars.
We've had just an amazing response from the Philippine students. Many autographs and more selfies than I can count.
Some even said that they want to become meteorologists themselves to help carry on the study of our home planet and how it's changing.
I feel hopeful. We're not getting any younger, and the number of atmospheric scientists in the Philippines, in the world, particularly in the Philippines, is quite small, and the kind of work that needs to be done to understand the different atmospheric processes in the region is quite a lot.
We are so dependent on this earth because we live here, we have to breathe here and find things to eat here. It's important that we understand it so that we don't inadvertently cause damage that could affect us all.